Welcome to the logi.DOC presentation. logi.DOC, the system-independent function plan editor for creating power plant documentation according to the standard VGB R170C. After you have installed logi.DOC for VGB R170C, you can find several sample documents in the logi.DOC installation directory. You can open these sample documents in the following way. As the project is open now, first of all, I would like to explain a little bit of the project structure. Here you can see the name of the project, in our case Rosbläser_0. Then you see a subdirectory for our signal database, a subdirectory for documentation management, a subdirectory for managing our documentation templates, a directory for storing our platforms, so-called block library, a documentation library including the plant identifier M, a directory for storing PDF documents, and, very important in this area, a link to the various block libraries that are included in the logi.DOC for VGB R170C shipment package. You can open all libraries, all documentation structures by clicking this plus, as you know it from the Windows Explorer. First of all, let's have a look into the block library, which you can find under the name R170C mod. Now, this block library contains a great number of modules, a great number of blocks that can be used for creating function blocks according VGB R170C. To begin this explanation, in this block library you can see a grouping, a classification of so-called document types of the VGB R170C standard. Of document type YFT for creating drives, YFS for creating sequences, YFR for creating controls, YFN for overview pages, and YFM for creating pages of measurements. If you open the block library named YFT, you can see here some standard blocks, for example, the representation of an operation mode or manual mode, a block for the single drive, a block for a control drive, a block for a set drive, or here a block for a two-direction drive. All blocks are collected here in this document object named Legende YFT. You can open this document object by double-clicking to this object. As this object is in fact just a so-called logi.DOC link to a real object, you cannot edit this object. But you can see here in this documentation object all essential function blocks which you can use for creating your function block plans. If you drag this rectangle in this overview window down, then you can have a look through this object, and as usual in logi.DOC, you can have a look at all objects in this documentation. In the next step, we will have a look inside the document structure of our project. You can see here, as a plant identifier, we have specified this with the letter M. And this document object or this document structure, as already mentioned, can be opened with this click to this plus. Below this plant identifier, there are the so-called function groups. Here you see 5 different function groups which describes this Rosbläser. Now we go deeper into the function group 2HHC12. First, let's go into YFT, because here we have the drives of our Rosbläser. Every single document is identified by the power plant identification system of this component. Separated by a double underline, you can see the long name of this component, and, as already mentioned, you can open this document by a double click. After you have opened this document, you can see the internal logic. Here you can see a so-called function plan sheet. On the left-hand side, there are the input variables. On the right-hand side, you can see the output variables of this drive. By clicking the zoom buttons, which you find here on top, you can zoom into this sheet. By changing the zoom level, you can now see the signals which are written by this drive block. If we zoom further, we see here the output signal of the drive, the feedback signal off, with the signal text XB04. Below the name of the signal, you see the long name with the signal text, and below of it, the fully automatically generated cross-reference for this signal as the so-called target reference. This cross-reference has been generated by logi.DOC fully automatically and saved into the so-called signal database. As a cross-reference information, you can see here the function group identification as the power plant identification of the target sheet position. You see the long name of the sheet on which the signal resides, and here you can see the short name of the sheet and the line number belonging to the position of this signal on the target sheet. For further editing and processing of the function plans and for tracing the signals within the function plans, the cross-reference of these signals is really important. If you position the mouse on this signal, you can open the pop-up menu by mouse button number 2. You can see here the menu item Go to Usage in POU. You can have the full cross-reference displayed, and you can open the document by navigating to the target position that belongs to it. This document is now the sequence of steps which gets this drive triggered in a certain step, and you can see this very clearly. At the position of usage, you see the signal with all its descriptive elements, and here you see the reference for the signal. The signal is built on sheet B02 in function group M2HCC12AA001. If you go further right, you see that the end conjunction is the transition condition and the activation condition for this step 17. If you go further right, you see which drive should be activated in step 17. Again, you see here, via the cross-reference, you can jump directly to the position of usage of this signal. After opening the target function plan, you see here that the drive is activated by step 17. If you now close all function plans documents, I would like to show you the so-called signal list. All PPLS signals which are used in this project are listed in the so-called SIG tab for you. In this SIG tab you can see all signals. You can see the identification of these signals, you can see which long names they have, which data types are used, and which signal text belong to these signals. If you select a signal, you can see how this signal is used in your function plan. Here you can recognize that in this document the signal is written to, which means that it's positioned in the right-hand value field area. And here you can see that the signal is read, so it's placed on the left-hand side of this function plan. And even from here you can open the function plan document which is referred to by this cross-reference. Here you see the open function plan, and you see that the signal is used as reading reference at step 07 of the sequence of steps. If you want to add a new signal to this signal list, you have on the Signal tab the opportunity to click mouse button number 2, and so you can add a new signal. You have a drop-down box for the selection of the data type you want to specify for the signal, and via this drop-down box you can define the signal text, and both pieces of information are defined in a so-called XML file that contains all definitions for these input boxes. If you have entered all information that's relevant, you can enter this signal into the signal database by clicking OK, and from this point of time this signal is ready to be used in your function plans. At the last topic, I would like to show you how you can manage your function plan documents and how to print them if you want to make hard copies. For this purpose, several document objects are stored in this documentation tab. You can open such document object as you already expect with a double click. Once you have opened such kind of document objects, you can see how they manage their documentation. They are a variety of a collection of sheets in this documentation object, which represents the whole documentation as a view on the whole project. You can create this documentation object as follows. Press and keep pressed mouse button number 1 on objects in the documents tree and drag these objects into the documentation object, and at a later point of time press to 1, 2, 3 to generate the table of contents. You see in this document object the long names of all document pages. You can also see in this so-called revision status for every single sheet. If the revision status is set to new, that means that, referring to this document object, no changes whether have been made of this sheet. In order to print this document, first of all you have to define the printer. Here, in this case, it is the so-called PDF creator. With this, you can create PDF files free of costs. Once the properties of printer have been set properly, you can, by clicking to this icon, you can transform the whole documentation object and its contents into a PDF file. Feedback on the ongoing printing progress is given by a well-known progress bar. Now here you can see the PDF documentation file with all the pieces of information that have been saved as the whole of this document object. These are the cover sheet, the automatically generated table of contents, and a logic sheet. That ends the tour in which I showed you the most important functions of logi.DOC, in which I wanted to show you how you can handle logi.DOC, the system-independent function plan editor, in an existing project. In the following training video, I will show you how you can create signals, how you can drag and drop blocks to documents, and how you can connect blocks to existing signals. In other words, I will show you how you can create a function plan document quickly and efficiently. In the meantime, have a lot of fun with logi.DOC.